So let's take a final look at some ln problems. These are a little bit different to work with. So remember, the big idea of what we want with the u is something that becomes easier to work with as I take derivatives. So up until now, we've always been saying something like u is equal to x squared, right? Taking the derivative of x squared, that makes it easier to work with. And that would give me v prime is equal to the ln of x. And this doesn't seem so bad to start off with. I'm going to get u prime then is equal to 2x. Now, what about v, though, in this case? What is the integral of ln of x? The integral of ln of x is not 1 over x. That's the derivative of the ln of x. You're going in the wrong direction. So what do I do here? And the answer is I stop and I think about how I would do it differently, right? So let's try this, actually. This is going to seem a little bit odd at first, but I'll take the ln of x is u. And think to yourself, does the ln of x become easier to work with as I take derivatives? And the answer is, oh yeah, it does. 1 over x is easier to work with than ln of x. I like it more. What would that leave v prime to be? Well, v prime then would be x squared dx. Can I take the integral of this thing? Yeah, so that passes the test too. Now, let's see what our u prime and our v would be. So u prime is going to be equal to 1 over x. V would be equal to x cubed over 3. So let's see what happens in our formula here. So the integral of x squared ln of x dx, so this is u, this is v prime, is going to be equal to u times v, so the ln of x times v, x cubed over 3, so this is u, this is v, and then it's going to be minus the integral of v, so x cubed over 3, times u prime, which is 1 over x, not x, 1 over x dx. So this is u prime. So I started off with this integral that I couldn't really do, and now do I have an integral that I could do? And it's a little bit disguised, but this is something that you can actually do without too much work, okay? So I'm going to simplify this over here. So I'll have x cubed over 3 ln of x, and then this is going to be minus 1/3, and x cubed divided by x, what is that? Well, that is just x squared dx. So I just end up with this integral that's actually really easy to work with. My final answer here is going to be x cubed over 3 ln of x minus 1/3 x cubed over 3 plus c. And this is really going to be minus x cubed over 9. Okay, so with ln's it works a little bit differently. Usually we end up picking a u is equal to x squared, but here u is going to be equal to ln x, because that also becomes easier to work with as we take derivatives, and it just usually works better that way for ln's.